Alright, hello, assalamu alaikum everyone. So, this video will explain you what hypothesis testing actually is, and then we will move on and do hypothesis testing on Poisson, binomial, and normal distribution. Okay? Alright, so this video is going to give you an overall structure of what hypothesis testing is. So, basically, let's suppose you say that there is a population data. So, you have population mean and you have population variance, and then you have your own sample via survey or via interview, whatever. Basically you have this, okay, and you have your sample mean. So null hypothesis says the hypothesis testing can be done on Poisson, binomial, normal. So in case of Poisson, we're testing the mean value. In binomial, we're testing the probability of success, and in normal, we're testing again the mean value. So you say कि भाई Poisson में lambda is this, binomial में probability of success is this, and normal में the mean is this. Now there's three types of alternative hypothesis for you. You say that your mean has decreased. You say that your probability has increased, or you say that your mean has changed. So these are three different alternative hypotheses that you can say, और इसके अलावा possible भी नहीं है. So changed means that it has either increased or decreased. Now I'm doing it with all three of them. So this decrease, increase, and not equal to can be applied to anything, to mu, probability of success, or the normal distribution mu. Okay? Now decreased means that it is not the same, so we call this as a lower tail test. Upper tail test, and this is a two tail test. So basically this is your claim and this is the population data. You have to test your claim against the population data. Okay? And then decide who is correct. Is the population data correct or your claim correct? This is what you have to decide. And for that you define the significance level. Significance level is your deciding criteria. So if let's suppose this is your 5% significance level, 10% significance level, 1% significance, 2%, 2.5, it can be anything, right? If your test statistic probability lies within significance level except alternative hypothesis, and lying within significance level basically means you lie in the critical region. If your test statistic value, if your test statistic probability lies outside significance level except null hypothesis, this is called null hypothesis, and this is called alternative hypothesis. Now, what happens to lower tail, upper tail, two tail? So if the significance level is 5%, we test it for 5%, we test it for 5%, but we test this one for 2.5% and 2.5% because it is equally divided to upper tail and lower tail. Okay? Now, 5% significance level. If I draw a bell curve and this is a lower tail test, so this is 0.05. Now this is a probability given to me. Probability of critical region, you can say, because this as part is called critical region. there is a z value of it, and there is also an x value of it. So the question can also ask you to find this z value or x value. Now you can get a better understanding of this concept using the past paper questions. Okay, let's look at that. Because for Poisson, for binomial, everything, the critical region and deciding criteria is a little different. Let's look at that. Flies stick to wet paint at random points. The average number of flies is 2 per square meter. A wall with area 22 meters square is painted with a new type of paint. So this is 2 per meter square. 22 meters square means the lambda value will be 44. They are saying this is fly repellent. That means you can say if null hypothesis, your lambda value is 44. Fly repellent means that they will be sticking less than 44 flies on the wall. It is found that 27 flies stick to this wall. This 27 is my test statistic. Use a suitable approximation. That means we can go from Poisson to normal. Why are we going from Poisson to normal? Because the lambda value is greater than 15. To test at the 1% significance level is my decision criteria. Take the null to be 44. So my lambda has been replaced with mu. Why? Because this is gone to normal distribution. Now probability of x is less than and equal to 27 is what you have to find out. And let's define the parameters. In normal, lambda is also 44 and mu, like mean and variance both are the same. So we will use this 44. Now apply continuity correction. Why apply continuity correction? Because we are moving from Poisson to normal. So this is going to be 27.5 minus 44 divided by under root 44. Minus 2.487. Let's do the forward reading for this one. Forward reading means finding out the probability. You can read the table, you can use the calculator. So this is multiply this by 100, we say this is 0.64. Now this probability is less than 1%. That means you lie in the critical region. So accept the alternative hypothesis that yes, the new paint is fly repellent. Acha, one way of doing it is that I reach the conclusion using the probability. You can also stop at z value. When I say 1% significance level and it's a lower tail test. So find the z value of this. How? By reverse reading. So using the calculator or the table, when I reverse read 0.01, my z value is, so you know this value of z is minus 2.326. So minus 2.487 will lie somewhere beyond that. That means it lies in the critical region. So accept H now. Alternative hypothesis. This is another way of doing it where you make the decision based on z value or you make the decision based on the probability percentage. Both of them are the same thing. There is no problem. ठीक है, अच्छा जी, let's look at binomial now. 1/3 of the voters in Shington voted for the Citizens Party. 1 year later, researcher questioned 20 randomly selected. Exactly 3 of these voters said. So this is clear binomial because उन्होंने probability of success आपको दी है. So they are asking 20 randomly selected and they are saying 1/3 voters vote for Citizens Party. Exactly 3 of these voters said that there was an election next week, that the vote test at the 2.5% significance level, there is a decrease in the support. So you say null hypothesis, my probability of success is 1/3. And in alternative hypothesis, my probability has decreased from 1/3 because you take this is a lower tail test. Exactly 3 of these. Since it's a lower tail test, so you will do for x is less than and equal to. That means 0 plus 1 plus 2 plus 3. What is the binomial formula? (20C0, 20C1, 20C2, then 20C3. And finding out the probability, we get the probability is 0.0604, which is 6.04%. Now this percentage is way more than 2.5%. So we say except H naught, that is the votes to Citizen Party have not decreased. That's my conclusion. So over here we were just doing binomial testing. Now let's find out a couple of more difficult questions. Okay. I'm doing mixed questions so that you can also identify and do mixed questions on your own. Now, from previous years' observations, the length of salmon in a river were found to be normally distributed with mean 65. So this is the population mean, you can say that. Researchers suspect that pollution in water is restricting growth. So you say that your length is 65, but alternatives say that it is becoming less than 65. Now, she then carries out, so normal distribution means going to be 65, comma. This is the unbiased estimate of the population variance. Okay. Divided by, do we have any sample size? The sample size is n. So whenever we are moving from population to sample and we want to map that, we always, the mean remains the same, but variance is to be divided by the sample size. Now, what is the test statistic value? Is this, and the z value for this has been given, which is minus 1.807, meaning there's no hypothesis testing required. It's just the concept that they're using. So I'm just standardizing it. We know that the z value is equals to minus 1.807. So let's find out the value of n from here. So this becomes So the number of sample sizes. Now using this statistic, carry out the hypothesis, tested the 5% level of significance and state what a conclusion would be. Alright, so over here it is given that the test statistic value is minus 1.807 and this is a lower tail test. So let's find out its probability. The probability is 0.035381, which is 3.5%. This is less than 5% significance level, except alternative hypothesis, because you lie in the critical region. That is, yes, pollution is restricting growth. All right, pretty easy questions, I would say that. Okay. Now, a clinic monitors the amount milligrams per liter of a certain chemical in the bloodstream of patients. For patients who are taking, it has been found that the mean value is this. Okay. Test whether the mean amount of the chemical in the bloodstream taking B is different from that of drug A. So you are saying that the mean is 0.336 and you are saying that it has changed. Now, how do we find out? Now, variance is not given, so we have to find the unbiased estimate of population variance. N upon n minus 1. What is n upon n minus 1? 100 upon 99. Okay, so this is 31.56 upon 100. So my unbiased estimate of variance is 0.1. Now, when we go for normal distribution, the mean value will be 0.336 because that's a population data. Unbiased estimate of the population variance divided by sample size. So yes, it's very important that population ka unbiased view, when you're moving it on to the sample, you have to divide by sample size. And your B ka mean is 43.5 divided by 100. 0.435, and you're going to do an upper tail test because this 0.35 is more than this mean. So we will test for an upper tail test. And since it's a two-tailed test and it's 1% significance level, so 0.5% will be equally divided. 1 will be equally divided. $2.77. It is 2.8 into 10 power minus 3. This is the probability. Multiplied by 100, I get 0.28%. Now this is less than 0.5%, except alternative hypothesis that yes, the mean, I would say, the bloodstream of patients taking drug B is different from that of taking drug A. Now next is, for the test to be valid, it is necessary to assume a normal distribution for the amount of chemical in the bloodstream taking. Justify your answer. Yes, it is important because of central limit theorem. What does the theorem say? The theorem says non-normal population is approximately normally distributed because the sample size is large. So what is the sample size here? Which is greater than or equal to 30. Over here the sample size is 100. So although it's not mentioned here that it follows normal distribution, but we still go ahead with normal. Why? Because the sample size is very large. Has been modeled by a random variable distribution with Poisson 0.7. Will increase first 5 days. Okay, G. 0.7 is for per day. For 5 days, it's going to be 3.5. Now they are saying that the null is that the lambda value is 3.5 and alternative is that this has increased. And my significance level is 10% significance level. Given that the total number of cars sold during the 5 days is 5. So it's an upper tail test. So this is what we're going to do. 1 minus probability of x less than or equal to 4. E to the power minus 3.5. Now, let's move on and do it. Find out the probability. 0.7254. So 0.2746, that gives you 27.5%. This is way more than 10%. Way more than 10% means accept null hypothesis, that is the lambda value is 3.5, that is the sales have not increased, they still remain the same. The number of cars sold per day another showroom has independent 0.6. Assume that there is still 0.7. Find the probability the total number of cars sold in two showrooms in 3 days is exactly 2. Now this is another topic's concept, but if you talk about 3 days, this is 0.6 or 1 day. 3 days will be 1.8. 0.7 for 1 day. 3 days will be 2.1. Total means you add the means, what you get. So we get 3.9. So x follows Poisson 3.9, and we have to find out the probability of exactly 2. So that means e to the power minus lambda, lambda to the power x upon x factorial. So this will be divided by 2 gives you 0.154. That's my answer for this one. Okay, in the next video I'll be discussing type 1 and type 2 error.